students, welcome again to my channel. This is Mr. Meshak Ngige with Math with Meshak Ngige. So kindly, if you have not subscribed, kindly subscribe, share, and also comment, and let me know how I can help out when it comes to issues mathematics. Now today we're going to be looking at the second question, that is from the NEC 2024 series. This is from matrices 2, and you're given a question, and the question is given when you're given differential equation given by this, and your matrix A is given by that, and you're told to determine QT, that is the state transition matrix. Then you show that this is rho, okay. When you place your value of t being equals to 0, your answer gives you the identity matrix. Now solution. So we know the equation that we have, that this matrix, the state transition matrix, will be given by the Laplace inverse of Si minus A. Then you do what? You get the inverse of it. So the inverse of this, then you get the Laplace inverse also. Then it gives you the state transition matrix. Now we determine the first part, which is Si minus A, which we said is S0, 0, S, okay, minus the matrix A, which is 0, 1, negative 2, negative 3. Then subtract, so S minus 0 gives you S, 0 minus 1 gives you negative 1, 0 minus 2 gives you positive of 2, then S minus 3, it gives you S plus 3. So your Si minus A is given by that. Now the second step is get the determinant. We get the determinant of Si minus A. And how do you get the determinant? Multiply the elements in the main diagonal, subtract the elements in the minor diagonal. So this multiplied by this, then this and this. So you have S into bracket S plus 3 minus 2 times negative 1 gives you negative 2, okay, but you have another negative here, all together. So this one becomes what? Becomes positive 2. So when you expand this, you shall have S, then is S squared plus 3S, then plus what? Plus 2. Now, as we checked, we have equations, and these particular equations, basically by the end of the day, you check if this quadratic equation can be simplified in terms of factors. If it can be simplified in terms of factors, then we shall use partial fractions altogether. Then if it does not, then by the end of the day we use what? We shall use completing the square method. So now we check this equation, particular equation, we check. So you have we have S squared plus 3S plus 2. Now, two numbers when you multiply you get 2, and when you add you get 3. That definitely is 2 and 1 altogether. 2 times 1 gives you 2. Then we have 2 plus 1 gives you 3. So we say this one can be simplified in terms of factors, and we shall have S plus 1, and we shall have S plus 2. Now remember, the factors here just says when you multiply this and this, by the end of the day it should give you this particular equation. So this part here just enables us to rewrite it. So therefore the inverse, now remember this is a determinant, and how do you find the inverse? Therefore Si minus A inverse is given by 1 over determinant. What is our determinant? This particular factor. So we have S plus 1, then we have S plus 2. Then into bracket, this is 1 over determinant, right? Then interchange the values in the main diagonal. So we shall have S plus 3, then we shall have S here, right, together. So interchange the values in the main diagonal, then change the sign in the values in the minor diagonal. So this one is positive, it changes to become negative. This one is negative, changes to become what? Changes to become positive, right, together. Now this one, the determinant now can open the bracket, multiplies with every value inside the bracket. So we shall have, so this one again gives us, we have S plus 3 over the S plus 1 s plus 2. Then you have 1 again over s plus 1 s plus 2. Then you have negative 2 over s plus 1 s plus 2. Then you have s again gives us s plus 1 s plus 1 then s plus 2. So we have that. Alright, so this one now is si minus a, then inverse of it gives us this. Now remember, we're supposed now to, for Laplace inverses, there are no inverses written in these forms, okay? There are no inverses written in this form, so we have to split this particular, this term into two terms using partial fractions. So, but you know, we have three ways of partial fractions, and this is always the first one, where you have two factors multiplied together. These values here, the values in the denominator. Remember, partial fraction focuses on the denominator by the end of the day, altogether. So, these two, anytime you have two linear factors multiplied together, then we say it will be written in the form of a over the first factor plus b over the second factor. So we shall check for all these values altogether. So each and every term will be checked individually. So we start with s plus 3 over s plus 1 then over s plus 2. So we have that. So we are saying this one will be written as a over the first factor plus b over the second factor. So we have that all together. Then again put this one in one fraction. What is the LCM of this and this? Of these two factors? It is just the multiple of the two all together. So s plus 1, s plus 2. So those ones are the that is the denominator, that is the LCM, because they are not the same altogether. And since they are not the same, this term here multiplies this multiplies this part. But you can always use the normal argument, but this one goes here this time, so you remain with what? S plus 2 times a. But to make it easier, this part multiplies this multiplies that, because they are not the same by the end of the day. So we have a over plus s plus 2, then plus b s plus 1. Now, if you check now, we have written it now, we have represented this fraction here in terms of this part. So we have our LCM here being the same. Altogether, you can see the LCM s plus 1, s plus 2, s1 plus 2. So therefore, if the denominator is the same, and this one is an equation, therefore, also the numerator should also be the same. So this numerator here should be the same as the numerator. So we shall have s plus 3 should be the same as a s plus 2 plus b s plus 1 altogether, because the denominators are the same. So therefore the numerator also have to be the same. Now we need to understand one drill here, and this will make it simpler, because when you deal with the first one, on the left hand side, or in my side I can call it the right hand side, the right hand side outcome for all of these partial fractions will be the same altogether. This part, so when you come to this one, the second part, you have 1 over s plus 1, s plus 2, again 1 over s plus 1, b over s plus 2, again just simplify, again take the LCM. So these parts will be repeated throughout, but now the only part which changes is the left hand side, because the values are different. So you will not have to be repeating this part again and again and again altogether. So what we shall just be changing is this part. So for instance, this part here we'll have now the right hand side being 1, then the left hand side being the same. Now to make it even easier, we are supposed to find the value of a and the value of b. Altogether, the value of a and the value of b are supposed to be found, so that we can rewrite this fraction here in this form. For example, I get my value to be 1, it will be 1 over s plus 1. Again, I get my value of b over 2, let's say 2, then over s plus 2, right together. So we're just determining the value of a and b. Now, the second drill now goes, we want to find the value of a and the value of b. So what you do here, you choose a value of s such that it will make one of the values to be zeros, either of a or b. So for example, we want to find the value of a. Which value of s can we choose to make this term to become 0? So which value can we choose of s? So we'll say when s equals to, so the only way to make this term here to be 0, I'll have negative 1 here, okay? So when s is negative 1, okay, what will I have? So when s is negative 1, I'll have, so every place you have an s, replace it with negative 1. So we'll have negative 1 plus 3 equals to a over negative 1 plus 2. Now this part here just becomes 0, so plus 0. Okay, so negative 1 plus 3 gives me 2. Then negative 1 plus 2 just gives me 1. 1 times a, 1a, which is just what? A. So therefore, your value of a becomes what? It becomes 2. Then the same procedure again, we say when, let me just rewrite it here, let me use this space. When s equals to, now choose a value here now that will make a to be 0. Here we made our b to be 0. Now what value of s can we choose to make this term to be 0? So I have 2, so the only value I can choose here is negative 2. So when a is negative, when s is negative 2, so replace negative 2 in all of this, so we'll have negative 2 plus 3, okay? Then when I put my value there, I'll have 0. Then plus b, I put negative 2, so it will be negative 2 plus 1. I hope you're following. Okay, so negative 2 plus 3 gives me 1 equals to, this is 0, negative 2 plus 1 gives me negative 1. Negative 1 times b gives me negative of b. Therefore my b divided by negative both sides gives me negative 1. So now you have your value of a being equals to 2 and your value of b being equals to negative 1. Therefore we are saying this fraction here, this 3, the fraction there, s plus 1, s plus 2, can be represented now as a is 2, so 2 over s plus 1. Then our b is negative 1, so I'll have minus 1, okay, over s plus 2. So I've just multiplied the 1 with the positive. So negative 1 here and we have a positive here, so it just becomes minus 1. So therefore this part has been given by that. Now, to make it now, as I told you, this part is going to be easy because you not need to replace, you not need to work out this other part. We know one thing, and I want us to understand it, that the right hand side will always be the same. So at any point I replace my s to be negative 1, the right hand side I'll always get what? A. Right? So 2, at any point on the right hand side when I replace my value of s to be negative 2, my value of b will be negative b. This side, the right hand side will always be negative b, the right hand side here will always be a. So what will be changing is only this left hand side. Now, so we have the first partial fraction, so we have the first one. Now let's check the others. So, okay. Now this will be simple. So we go to the second one. 1 over s plus 1, s plus 2. So again, now remember, we don't have to rewrite this part. Why? Because we just say our value will be this is the same. Our numerator will be the same. We just have these partial fractions anyway, but you can just write it for the sake of writing 1 plus b s plus 2. This one again becomes a s plus 2 plus b s plus 1 over s plus 1 s plus 2. But now this side we have 1 equals to s plus 2 plus b s plus 1. So we have said when our s will just have the two values alternating, negative 1, we shall have, now the right hand side we don't have what? We don't have an s, so we just have 1. The left hand side we have said the answer will always be a. So my a equals to 1. Alright? When s equals to negative 2, we have said this right hand side is 1, there is no s, so it's just 1, equals to the left hand side we have said we get negative b, so my b therefore in this case will be negative 1. I hope you really understand that. So therefore my partial fractions, this partial fraction will be given by, therefore 1 over s plus 1 s plus 2 will be given by a is 1 over s plus 1, b again is minus 1 s plus 2. You have that. We go to the next one. The next one is negative 2. So negative 2 again over s plus 1 s plus 2. So you can see I'm just repeating the same thing. A over s plus 1 plus b s plus 2 equals to again a s plus 2 plus b s plus 1 all over s plus 1 s plus 2. Now again I just come here directly. When s equals to, okay, when s equals to negative 1, all together, when s equals to negative 1, on the right hand side I don't have a what? I don't have an s, so I'll have negative 2 equals to, the right hand side is always a. So therefore my a is negative 2. When s equals to negative 2, the right hand side does not have an s, again it will be negative 2, but the other side the answer is negative b. So divided by negative both sides, my b will be equals to 2. So now we can rewrite now our negative 2 over s plus 1 s plus 2. Okay, so therefore this will be written by our value of a is negative 2 over then we have s plus 1. Our value of b is 2. Okay, so plus 2 over s plus 2. So therefore for that value we have that. Now for the last one, which was s over s plus 1 s plus 2. Again we are saying this one is a over s plus 1 plus b over s plus 2, and again this one we are saying it just gives us a into bracket s plus 2 into plus b into bracket s plus 1, and then all over s plus 1 into bracket s plus 2. Okay, so we just take this side and this side, so we have s equals to a s plus 2 plus b s plus 1. So we have said now when s, we now take when our s is negative 1. So when s is negative 1, so you can see on the left hand side we have an s. Okay, so therefore the value of s there shall be replaced by negative 1. So we have negative 1 equals to, so remember when it is negative 1 we're eliminating b, so we made it negative 1 plus 2. So we shall have a negative 1 plus 2. This one becomes 0. Are we together? So it is just negative 1 equals to, and this side again we just said we will always have our value as a. Just done the whole process, but now therefore our value of a becomes negative 1. When s equals to negative 2, So again, we have negative 2 this side, but this side we said we'll have negative b. Okay, so that's what we have here. So therefore, our b in this case will give us what? Will give us 2. So this part here now will be represented by, rows of value a is negative 1 over s plus 1, then plus 2 s plus 2. So that is your representation for this part, for s over s plus 1 into bracket s plus 2. So now we have all of them, the 4 of them. So we have this one, we have this, we have this part, we have this part, we have the one that we have for 1, and the one that we did, which was giving us the value of what? The value, the first value. So we can now rewrite the whole matrix now in the partial representation. Are we together? Now something to note when it comes to values, let's say an equation which can be broken down into factors, by one way or the other, those answers leads to the Laplace inverse of an exponent at. So the Laplace inverse of 1 over s minus a, 1 over s minus a always goes back to that. So we have, because you can see this part here is s plus, okay? So we shall see what will be the actual value of a when we rewrite it. So now let's rewrite the whole matrix. So now when we rewrite all these partial fractions, we'll have that the first part of the matrix becomes this, the second part or the second element becomes this, the third, and then the fourth. Now from there now we get the Laplace inverse. Now remember, I've said that these one will become exponents by the end of the day. So you have to remove all the constants, for example the places that we have 2, negative 2, 1 and so on, so that at the denominator, at the numerator, you have a 1. Are we together? So that you have a 1. So therefore we're saying, so if I write that, just have these. So I just remove the constants of the Laplace inverse of, so I remove 2, I remain with 1 over s plus 1. Okay? And the other one, it is negative 1, so it just remains to be negative s plus 2. And I go to the next one, remains the same, s plus 1. The next one, again it is 1, so it just remains the same, plus 2. Then we have negative 2, we move it outside, so that we remain with 1, s plus 1. Then the next one we have plus 2. We have 1 over s plus 2. Then the last one we have negative 1 over s plus 1. Then the next one is 2 over s, we remove 2, sorry. So now from the Laplace inverse we know one thing, that 1 over s minus a is the function that gave you this transform was EAT. Are you together? So EAT, the Laplace of EAT is 1 over s minus a, and you can see all these terms have 1 over s minus a. Now what we just changed is the value of a. Now note something, this term is supposed to be written in the form of s minus the sign between should be a negative, right? But here it should be a negative, but in our cases here we have a value being positive. So that means the only way the central sign or the sign that joins between the s and the a can be positive is only when your a is a negative value. That is to say, if I have s minus and I have a negative value of a, then when I open this bracket I'll have a s plus a. Are we together? So I'll have that. So therefore it means all the values of a here are all negatives. So therefore we're just saying, therefore our state transition matrix now will be given by, so it will be 2 exponents, our value of a is 1, so it is negative t, it is negative 1t, right, minus exponent of, our value here is 2, but it will be negative 2t, then we have e negative t, minus e, negative 2t. Then here we have negative 2 exponent negative t. Then we have plus 2 exponent negative 2t. Then we have negative e t. Then plus 2 exponent negative 2t. So you can just see the exponent values are just the same. E negative t, e negative 2t, e, t, e. So whatever just makes the difference is when you have the constants. It's just these constants that makes the matrix to be different, but the outcome is just the same. Therefore, your state transition matrix will be given by that. Okay. Now the second thing is to show. The second part was to show that when you replace 0 in the value of t, you get identity matrix. Now let's see how true that one is. So you have 2 exponent. When you replace here 0, just have 0, minus e, negative 2 takes 0, just 0. Then you have e, then again 0, minus e, negative 2, again 0. Then you have negative 2e, 0, plus 2 exponent 0. Then you have negative exponent 0, plus 2 exponent 0. Okay. Now any value to power 0 is 1. So 2 times 1, this one is 1, this one is 1, 1, 1, 1, 1, 1, and 1. Now, so we just handle them with the constant. So we have 1 times 2, 2. 2 minus 1 just gives us what? Just gives us 1. Then you have 1 minus 1 gives you 0. Then you have negative 2 plus 2, which gives you 0. Negative 1 plus 2 gives you 1. So remember, all the exponents becomes 1s because they add to power 0. And indeed, this is what you call the identity matrix. So therefore, you have proven the second part and you acquire yourself 10 good marks in your final paper. So thank you and see you in the next lesson.